Students working with the Parallax BoeBot may have difficulty programming turns because there are several steps between picturing the turn and coding it. To understand this video, you should already be comfortable writing the code to control a continuous motion servo. A pulse must be sent out every 20 milliseconds. Pulses are sent to a pin connected to a servo, and the pulse lasts for duration. And the number of pulses determines how long the motion will continue, and that is defined by the counter in the for next loop. The duration of the pulse determines the direction and the speed of the wheel. When the servo receives a pulse with duration 750, it will stay still. A value below 750 creates clockwise rotation, and a value over 750 powers the servo counterclockwise. And last in our review, remember that the Parallax BoeBot is a tail dragger, so the perspective for left and right is looking from above the BoeBot and with the ball towards the viewer. The blunt end is the front, and the ball end is the back. The left wheel is connected to pin 13, and the right wheel to pin 12. Each wheel has 3 possibilities of rotation: clockwise, counterclockwise, and still, to make 9 possible motions. This video will explain how the Parallax BoeBot moves for each of these 9 possibilities. The first 3 motions are easy because they are straight-line motions. To create forward motion, the left wheel goes counterclockwise and the right wheel clockwise. Reverse those, and the BoeBot moves backwards in a straight line. When both pulses are 750, both wheels are still, and the BoeBot holds. Those motions fill 3 cells in our matrix. Now for the turns. There are actually 6 turns, not just simply left and right. The kinds of turns vary according to the pivot point, which I will indicate with this symbol. The first 2 types of turns are tight spins, where the pivot point is in the middle of the Parallax BoeBot. Both wheels are rotating in the same direction, either clockwise or counterclockwise. These spin turns fill in 2 more of the possibilities in the matrix. A different kind of turn is where the pivot point is over one wheel, which remains still. The wheel pivot actually gives us 2 types of turns. Consider a left wheel pivot. The left wheel stays still, and the right wheel can rotate clockwise to move the nose forward in a counterclockwise turn, or the right wheel can rotate counterclockwise, moving the nose back and the BoeBot in a clockwise turn. Left wheel pivots fill in 2 more spaces in the matrix. And of course we can do the same with the stationary right wheel being the pivot point. If the left wheel rotates counterclockwise, then the nose moves forward to create a clockwise turn. If the left wheel rotates clockwise, that brings the nose back and turns the BoeBot counterclockwise. Adding those 2 right wheel pivots fills out the 9 possibilities of motion for the Parallax BoeBot. To review, with 2 wheels each going clockwise, still, or counterclockwise, there are 9 motions for the BoeBot. The 3 straight motions are forward, still, and reverse. There are 2 spin turns with the pivots in the center of the BoeBot, and there are 4 turns where the pivot point is a stationary wheel. If you have an idea for animating a BoeBot concept, please send us an email. John is available for on-site seminars in robotics, and take a look at BoeBotTeacher.com for more information about the Parallax BoeBot.